right, let's get started. So, welcome everyone. When I first started my professional career back in 2008, we only had a few data privacy regulations in place. The restrictions were relatively lax, and unless you worked for regulatory industry, you could process and store data more or less the way you wanted. Penalties, if any, were really small, and so it was mostly not a big deal. But then came the year 2016, and everything has changed, at least in Europe. In 2016, the General Data Protection Regulation, GDPR, was approved. Everyone was talking about it, right? It affected thousands of customers, thousands of companies, and it was really a huge deal. So raise your hand if you've ever struggled to implement these privacy regulations. Okay, I see most of the people had similar experience to mine. Implementing these regulations can be really, really hard. So today, I want to show you 3 solutions, 3 simple ideas to help you become GDPR and CCPA compliant using DLT. But before I do that, let me quickly introduce myself. My name is Marcin Wojtyczka. I work at Databricks as Senior Resident Solutions Architect. I work with customers and I help them with data engineering and data architecture problems. So without any further ado, let's get started. So I'm not a lawyer, but I'd like to share with you some basic information about GDPR and CCPA. Basically, these regulations focus on personal identifiable information, what we call PII for short. It's basically any information that can be used to uncover individuals' identity. This could be email address or phone number. And if you process data within EU or you offer any services to individuals in the EU, you basically must be compliant with GDPR. So it applies to any organization and it protects EU citizens and residents. And it imposes several requirements, like right to be forgotten, data retention, or right to access. Right to be forgotten, which is one of these specific requirements, means that if I am a customer, I have the right to request my data to be deleted. So this will be focused on my presentation today. And if you get such a request, you have basically 30 days to delete that data. In certain circumstances, it might be 90 days as well. Now, when it comes to CCPA, it's the California Consumer Privacy Act. And it's very similar to GDPR, but it protects citizens of California. And it only applies to bigger businesses. So you need to have at least 50,000 people and have certain amount of revenue. So the question is, why should you care about these regulations, right? The simple answer is that it may cost you a lot of money. And let me give you a few examples. In May 2023, Meta was issued 1.2 billion fine related to GDPR breaches in the Facebook service. This was one of the biggest GDPR fines so far. Then in the same year, another company, Criteo, was fined 40 million for GDPR breaches. And among other things, they were accused of non-compliance with right to be forgotten. And then, same year, Expo Italia was fined 10 million for processing outdated customer data. So apart from direct financial losses for non-compliance, you could also face legal challenges related to customer lawsuits. It can cause business disruptions, right? Because the system may have to be taken offline or modified. And it can also lead to loss of customer trust. So now that we understand these regulations and why it is important to be compliant, let's look at some of the common approaches to handle right to be forgotten. And this could be anonymization, pseudo-anonymization, data masking, or complete erasure of PII data. And all these techniques are great, but keep in mind that there are basically many examples in the industry where anonymization was done in a wrong way. And we were able to basically re-identify individuals. So your safest bet will always be the complete erasure of data. And this is also a focus of my talk today. So in this talk, I will present solutions that use delta live tables, right? DLT for short. I'm sure most of you already know this. DLT is basically declarative ETL framework that we developed. And with that framework, we can very easily build ETL pipelines. But yeah, the techniques I will show you today will basically be applicable outside DLT as well. So nowadays, with Delta and ACID transactions, deleting records is a trivial task, right? You just fire a delete statement and off you go. After that, there is just a little bit of, let's say, housekeeping. So you need to run a vacuum to physically remove the data from the cloud storage. So the moment you actually issue a delete statement, the data is not physically removed from the cloud storage yet. So you have to run the vacuum as well. And if you use deletion vectors, you must also enable, or you must also run the reorg table command. Yes, for those of you that don't know, deletion vectors is a storage, let's say optimization. What it does, it marks the records as deleted. And when you query the data, it will filter them for you, right? So that you don't see the deleted data. So with this deletion vectors enabled, data is actually not physically removed from the underlying Parquet files. So to force the removal, you have to run this reorg table command as well. But unfortunately, the reality is not so simple, right? In real life, we may have hundreds of tables, and any of these tables can contain like PII information. And we need to be able to find this information, right, in all these tables, and then we need to be able to delete that information. And while we are doing so, we also want to make sure that we don't disrupt any existing pipelines that are running. So in this talk, I will focus on deleting PII data, but I suppose identifying PII data is a big topic and probably a topic for another talk. So now let's step back a little bit and look at this simple DLT pipeline, for which we use streaming tables. So in this pipeline, we consume data from the Delta table and write to another data table. Seems easy, right? So let's see what happens when we delete a record. So let's see what happens when we delete a record from the table that is used as a source for that job. Basically, this job will fail, right? And this is because DLT streaming can only really handle input that is append only. Yeah? So if you try to do any modification to a table that is used as a source for streaming, the stream will break. There are also some other operations that can cause that, but basically any modification to the table will cause that streaming to fail. So we can only allow like append only inputs. So let's see what we can do about this. Imagine that we have the following pipeline. The data is read from the source incrementally in the bronze layer and then processed through silver and gold. Now a request comes to drop a personal data of a user. So to handle this, we can limit the retention time in the source so that we don't have to deal with the data that we read from. So we can send the retention time to, let's say, 30 days. And that's fine because we're going to have all this historical data in the bronze layer anyway. So when it comes to the bronze layer, what we can do, we can, of course, remove the sensitive data from that layer. In that case, we remove a data from a specific user. And now, next, what we can do, we can propagate these changes to all other layers. In that case, we can use materialized views. And yeah, we used to call them live tables as well. So you probably can see it still in the documentation. But these materialized views basically will recompute your tables. And it will do that, or it used to do that until very recently, it used to do that fully. So it fully recomputed the table. And last but not least, you would run a vacuum command. In fact, for DLT, this will be done for you automatically. So you don't have to run it yourself. Right, so great. Now we have a pipeline that is compliant with right to be forgotten. However, one issue that I want to call out here is that with this architecture, silver and gold tables will be fully recomputed, right? And ideally, we want our processing to happen incrementally. So we don't want to recompute all the data we already processed, right? So to fix this issue, we developed this amazing technology that we call incremental refresh, and internally it's known as Enzyme at Databricks. So Enzyme uses this cost-based optimizer, and it understands the data and it understands the query. And based on that, it will try to find the best strategy to refresh that materialized view. So it will either do it incrementally if it can for certain type of queries, or it will fall back to a full recomputation. So this can have a huge impact, on performance and cost. And currently we support, quite a lot of query types in Enzyme, and this is being constantly expanded. So now if we take the same pipeline, again, we want to process the data incrementally. We just need to enable Enzyme. In that case, we need to enable change data feed. That's the only thing that is required. And now, if the type of the query we use can be incrementalized, Enzyme will incrementalize it for you. So the refresh will be incremental. If you want to know whether a query is incrementalized or not, you can actually look at the Delta Live Tables event log. All right, but the question is, what if the type of the query we run is actually not supported by incremental refresh? Oops. So the simplest solution would be to actually replace the materialized views with streaming table. In this example here, we use streaming table now for silver instead of materialized view. Now, when the request comes to delete the PII data, we can drop that record, from the bronze as before. However, the problem is that when we delete a record from the bronze, the silver layer will break, right? Because that's what we were discussing before. We can only have append-only inputs to the streaming. That means our silver layer won't work anymore. But there is a trick that we can do here. We can use this skip change commit option, and that will basically skip all the modifications. It will only allow append-only queries to come in. So we will only consume append-only queries. But because we skip all deletes, one disadvantage is that we have to run this delete on the silver layer as well, right? Because we are not propagating it from bronze to silver automatically. So there are more tables we have to we have to manually maintain. So there are more tables where we have to run the delete command. So let's explore one more idea. The simple and most, I would say, elegant solution is to store PII data in a separate table. So in one place, that is our source of truth for our PII data. That table can have a surrogate key, like here, customer ID. And that customer ID we can use, in all our tables. So we don't have to drag all our PII information, across all these tables. We can keep it in one place and use the customer ID in all other places. And if we want to enrich our data analytics with PII, we can always join back by this customer ID to our table, to our PII table. So when a request comes to delete a personal data of a user, all we have to do is to delete that user from that PII table. And the whole system becomes compliant, right? So there are no other tables you have to touch. That's the only place you have to, you basically care about when it comes to GDPR. The small disadvantage of this solution, of course, is that we have to do this join. So there is a little bit, of complexity here, and this join will be required if you need a PII data. Another thing is that if you have an existing data model, you will likely have to refactor it. All right? If you haven't started with that design yet, you will have to refactor it. But this is one of the best solutions if you start with existing, especially if you start with a new system, right? You build a new data model, that's probably the way to go. Okay, so to recap the solutions presented, solution one, use materialized views to propagate, deletes across the tables. So we only really cared about the bronze layer. And it would be most useful, if the query can be incrementalized, of course. That would make it a really performant solution. If that is not possible, then what you can do, you can use solution two, and where we replace basically materialized views with the streaming tables. And then we manually remove records from tables that contain PII data. So this will probably not be acceptable if you have a lot of tables, because you have to visit a lot of tables to remove the data. And the last solution, which would be recommended for most situations, especially if you build a new data model. In this case, we separate PII data from rest of the data. And this will make it very easy for you to handle GDPR requests. So you can read more about these solutions in my Databricks blog post. So thank you very much for attending.